Hello. In this video, we're looking at angles some more, and in particular, we're going to be looking at angles formed in parallel lines. So for this, there are three rules that we need to remember, but before we get onto those rules, let's talk about what we mean when we say parallel. So let's say I've got a straight line like this, then I would say that I've got a line that is parallel to that if they are going in the same direction, like this. So if I were to carry these lines on, so say this line carried on like forever and ever and ever in that direction, and this line carried on forever and ever and ever in that direction, then those lines are never going to meet. They're like train tracks, right? So those lines would be parallel, whereas if I had something like that, then those lines aren't parallel, because I can see if I were to carry this line on at some point, just off my screen probably, they would meet and they would cross over, right? So those lines aren't parallel, whereas if I've got two lines going in the same direction like that, then those would be parallel. And the way that we show that we've got lines that are parallel, the way that we sort of mark it on our diagram, is with a couple of little arrows. So I'll put like an arrow on this line and an arrow on this line, and that tells me that what I've got is a pair of parallel lines. Okay, so let's get on to the rules that we need to know. So the first one is about corresponding angles. And the rule is that corresponding angles are equal to each other. So what do I mean by corresponding angles? Well, what we've got here is a pair of parallel lines, and then we've got another line that's cutting through them. And you can see that we're making a bunch of angles when we do that. There are 1, 2, 3, 4 up here, and there are 1, 2, 3, 4 down here. And the corresponding angles are equal, so that means that this one is corresponding to this one. Can we see how they're corresponding? They're sort of in the same position in this top cross as in this bottom cross. So those two angles would be equal to each other. So too then would be these two angles. So this orange one and this orange one are going to be equal to each other because they're in the corresponding position, this place and this place. These two angles as well would be corresponding. So this one here, and can you guess which the other one is going to be, the corresponding one? Yep, it's that one there. And then there's one final pair, which is obviously going to be this guy and this guy. So corresponding angles are equal, means this angle is always the same as that angle, this one the same as that one, this is the same as that, and this is the same as that. Good. So let's look at the next rule then. The next rule is about alternate angles, and this is the same sort of idea, but they're not in the corresponding position, they're in the alternate position, so it's sort of like the opposite of that. So if I start with this angle, say, the angle that is alternate to that is this one here, and those would be equal. So a good way of thinking about it is in this crossy bit here, we've sort of got a top left, a top right, a bottom left and a bottom right angle. This is the bottom right angle in the top cross, and it's alternate with the top left angle in this bottom cross. So top left, bottom right, those guys are alternate, and because they're alternate, that means they're equal. So what else have we got? What other alternate angles have we got? Well, this one is alternate to this one, yeah? Also, this one up here is alternate with this one, and similarly this last one, final pair, is alternate with this one. And we sometimes call these ones, my red and orange ones, are the interior alternate angles, and these ones are the exterior alternate angles, but we don't need to know that. And final rule then is called co-interior. There are a few different names for this one, but I'm going to call them co-interior. And the co-interior angles add up to 180 degrees. And this is an easy one to spot. Co-interior are just the angles that are together on the inside. So for instance, this one and this one. So those would be co-interior, and they're going to add up to 180 degrees. So like on a straight line or like in a triangle, they add up to 180 degrees. And the other pair of co-interior angles, perhaps you can guess, is this one and this one. So interior, meaning on the inside of my parallel lines rather than the outside, inside, and co, meaning sort of like together. So these are the ones that are together on the inside, and these are the other ones that are together on the inside, and those are going to add up to 180 degrees. So we've got our three rules here. We've got the corresponding angles are always equal. They're in corresponding positions on the two parallel lines. We've got alternate angles are also going to be equal. And we've got these co-interior angles. I'm just going to go through one of these diagrams. Let's choose this one. And I'm going to put in an angle. So let's say I told you that this angle down here is, let's say, 75 degrees. Now, if that was 75 degrees, we now know a whole bunch of things, don't we? Because alternate angles are equal, this one is alternate with this one up here, right? So that one's got to be 75 degrees too. 75 degrees. What else do we know? Well, we know that vertically opposite angles are equal. Do you remember that? If we've got a couple of straight lines that cross each other, the ones that are opposite are going to be equal. So if this guy is 75 degrees, this guy's got to be 75 degrees as well. So you can pop in a 75 over here. And then similarly, this one that I marked in red is alternate to this one that I marked in red. So that's got to be the same as well. So we've got a whole bunch of 75s. And how about these other ones? These angles were all acute angles, weren't they? They're all smaller than 90 degrees, so these ones are different. They can't also be 75 degrees. How can I work out what that is? So let's concentrate on this blue one at the top to start with. I know that this here is a straight line. On a straight line, the angles have to add up to 180 degrees, don't they? So if I've got 75 degrees over here, what am I going to need to make a whole straight line? It's going to be 105 more, isn't it? 105 degrees. Good, so we've got 105. That one is alternate. I've marked it in blue up here. It's alternate to this one down here. So that's going to be 105 degrees as well. And then we can think about our vertically opposite angles again, maybe. We've got a couple of straight lines that cross each other, so the opposite angles are going to be equal. If this is 105, this has got to be 105 as well. 105 degrees, good. And there's one final angle. Can we guess what it's going to be? Yes, you're right, it's 105 degrees. So, when it comes down to it, if we apply all of these rules that we've learnt, when we're in this kind of situation where we've got a pair of parallel lines and another one that crosses through them, there are only ever two angles that are made. There's the obtuse one and there's the acute one, and they're the same as each other. So the obtuse ones are all the same, the acute ones are all the same as well. Okay, so let's look at some specific examples here. So I've got a question here that says, find the size of angle BFE. So first of all, let's work out where angle BFE is. So I'm going to mark that in red, BFE. Well, here's B, here's F, here's E. So BFE must be this angle. Okay, good. If we're going to find the size of angle BFE, we're going to need to use this fact here. So I reckon this angle and this angle are corresponding. What do you think? They're in the sort of corresponding positions, aren't they, on this top line and this bottom line? And because they're corresponding, that means they're equal. So this one has to be 57 degrees. So I could write as my answer, angle BFE is equal to 57 degrees. There we go. Good. Let's look at another. Find the size of angle ABF. So again, first thing we're going to do is work out which angle we're talking about. So where's ABF? We've got A to the B to the F. ABF, that's this one here, isn't it? Good. So a few ways I can think of that we could work out what this angle is, but I reckon the easiest and the fastest way is going to be to use the fact that these two are co-interior. They're together on the inside of my parallel lines, these two here. So co-interior angles, do you remember the rule about co-interior angles? They're going to have to add up to 180 degrees. So I'm going to have to do a wee bit of a calculation here. I've got 125 so far, so that one is going to be whatever else adds up to make 180. So 180, take away 125. Let's do that calculation just quickly here. Can't take 5 from 0, so we're going to do a wee borrow. 10 take 5 is 5, 7 take 2 is also 5, 1 take 1 is nothing, so I've got 55. 55 degrees, there we go. So I would write as my answer angle ABF equals 55 degrees. Okay, one final example using these rules. We're looking this time for the size of angle TUV. So let's find TUV. on my diagram. So T's over here, U's over here, V is up here. So that's this angle that we're after. How are we going to work that out? Well, again, there are a few different ways. I reckon I'm spotting straight away that this angle and this angle are corresponding. They're in the sort of corresponding position on the two parallel lines, so this one has got to be 136 as well. And now that I've drawn this in, I can see that these two angles are vertically opposite. We've got that situation with two straight lines crossing, so the opposite angles are going to be equal. So if this is 136, this is also 136. Now you might have spotted that there was another way I could have got there. I think that these two angles, the one we know and the one we want, are in fact alternate, aren't they? So I could have said these two are equal because they're alternate angles as well. But I've used two of our rules. These ones are corresponding, and then these ones are vertically opposite, and I've got to the same answer. Angle TUV equals 136 degrees. Okie dokie, that's us sorted. Cheers, I'll see you in a bit. Bye-bye.